Hey, in the last video we extracted gold from a MacBook. It's a modern device and there is not much gold in it. Everything is way too optimized to cut costs. But when it comes to old school electronics, it's a completely different story. First, the gold plating is way thicker. Second, they used it a lot more generously. In this video we're scaling things up. We are going after a bunch of old gold-rich devices and we're gonna extract… well, I won't spoil how much just yet, but let's just say it's a lot more than last time. So why is gold even used in electronics? It's not like in jewelry, it's not for show. It's there for purely technical reasons. Reason number 1. Corrosion resistance. Unlike iron, copper or aluminum, gold doesn't react with air, it doesn't oxidize. If a connector isn't gold-plated, give it 8 to 10 years and it ends up looking like this. Reason number 2. Conductivity. Gold carries signals extremely well, with minimal loss. That's why hardcore audiophiles buy insanely expensive gold-plated cables, to reduce noise and interference. Reason number 3. Durability. Gold coating is surprisingly tough. Imagine plugging the same connector in and out 10,000 times. Gold can take that abuse and still keep the contact protected. Back in the day, soldering and assembly processes were less refined, and the tech wasn't nearly as precise. That's why older parts had way thicker gold layers. Just look at the difference between old CPUs with those fat gold pads and today's chips where the layer is extremely thin. So, if we want to make some real money, we need old electronics. That's where the gold is. We headed to a flea market where random people sell all kinds of stuff to see what we could find. Most of the time, nothing valuable, just junk. But then we spotted this old school desktop computer, and the seller let it go for next to nothing. The chunky monitor. Haven't seen one of those in years. We hauled it back to the car and kept looking. The booths were full of random electronic scrap, not all of it worth grabbing. I spent a lot of time researching beforehand, so we wouldn't miss anything valuable. Then I came across these circuit boards. People call them greenies. They don't look like much, but the chips on them, they likely have gold inside. And they were super cheap. Eventually, folks there started offering us everything they had, but we had to filter stuff. This older guy had a whole pile of radio parts laid out. Mostly junk, but I noticed a few pieces had that gold shine. Salt. It's been a while since I've been in a place like this. You can seriously find anything. There were even old phones lying around. We wandered for about 2 hours. And once our bags were full, we headed home and hit the classifieds. A lot of people are selling ancient electronics online, but some of the prices are just ridiculous. In many cases, I wasn't even sure we'd break even. Some listings straight up said perfect for gold refining. So, once we gathered everything up, we headed back to the garage. We ended up with quite the haul. Here is what we got. 4.6 kilograms of old RAM sticks. Some of them are ancient. There are even modules with just 64 megabytes. There is definitely money to be made here. 10 kilograms of greenies. Circuit boards from TVs, VCRs, radios and other old electronics. They're not the most valuable category, but there is still gold in them, mainly inside the chips. 2 kilograms of loose microchips. It's hard to tell how much gold is actually in this. And now the most exciting part. 2 full boxes of super old school mobile phones. The kind with antennas. I didn't even grow up with this, but back in the day they were premium tech. And finally, the big one. 30 kilograms of motherboards. Including some seriously vintage stuff. there is no doubt we'll be digging gold out of this. Next up, CPUs. We've got some regular ones everyone's seen before, but also some really old ceramic-based processors. Those actually have more gold in them. And then there is this giant bag of mixed radio parts. It's just a pile of everything. Some of it looks like it's from 60 years ago, but most of it pretty much junk. So we need to sort it all out first. We go through transistors, connectors, microchips, and wow, it's a pain. Everything's caked in decades of dust. Wait, found something? Some kind of gold-plated connector. Definitely a few interesting pieces in there. Oh man, we've stockpiled a ton of raw material. Let's start with... I really want to check out that old computer. No clue what year it's from, but it's straight up dinosaur. We plug in the mouse, keyboard and speakers. Power it on and it boots. It's running Windows XP. And there are still a bunch of programs installed. No way! GTA Vice City! That game came out in 2002. There's even a save file from whoever owned it. I ended up just sitting there playing for a while, brought back childhood memories. Yeah, I've played it on modern PCs, but this felt totally different. The monitor actually felt weirdly smooth, almost like it was running at 144 Hz. Until it froze. Time to pop the cover off. Inside we've got a motherboard, a graphics card, RAM and a CPU. But honestly, we started feeling kind of bad about tearing it apart, especially since we already had plenty of components. So we moved on to the motherboards. The most valuable parts here are the chipsets, like the North Bridge and South Bridge. We desoldered them using a torch. Also pulled off the connectors with visible gold plating and the CPU socket. But doing that alone would have taken forever, so I called in some help. Once we teamed up, things went way faster and a lot more fun. The job was simple. Heat up the solder with a torch, pull out anything that might contain gold, and sort it as we go. Only issue? The smoke. Tons of it. The fiberglass in the boards gives off this nasty sharp smell when it burns, and since the garage wasn't well ventilated, at one point it got so bad we could barely breathe.
Shit, that's impossible.
Then a neighbor came over to complain we were stinking up the whole block. So yeah, time for plan B. We packed everything up, loaded the car, and headed up into the woods to finish the job far from people. We have to drag all our gear with us, but at least out here the wind carries smoke away and the air is fresh. The whole process took forever. We didn't even film some of it, we just focused on working. By now it's second nature, visible gold plating goes in one pile, chips in another. After finishing up with the PC boards, we jumped straight into processing the greenies. There were a few gold-plated connectors here and there, but most of what we found were microchips and ICs. and those needed to be desoldered too. We worked late into the night, but finally got it done.
Oh, man, that took forever.
And here is the result, a pretty solid pile of chips and connectors. We packed everything back up. By the way, our clothes still reeked from that burnt plastic smell, and even our hair stank. The next day we got an early start to squeeze in as much as possible. From the PC boards we ended up with a whole container full of connectors, sockets and anything with visible gold plating. We also had a separate container for chips and another one for chipsets, the ones that coordinate everything on the motherboard. These are seriously valuable. All the chips, we dumped them into a big basin. That included the chips from the green boards, the whole bag of microchips we bought earlier, and even a shipment that showed up that day with more ICS. All of it went into the same basin. Meanwhile, the gold-plated connectors from the green boards went into this container. Each type of material will need a different recovery method. And as for the leftover junk, straight to the trash. We're still a long way from the chemistry and actual gold recovery. Right now it's all about preparing the materials. We've already dealt with the motherboards, the greenies and the microchips. What's left? Everything else. Let's start with the RAM. These are old modules, which means more gold on the contacts, on the board itself and inside the memory chips. But each part has to be processed differently. So we need to separate the chips from the sticks. We assume this step would be less smoky, but nope. Even the fume extractor couldn't keep up. So yeah, once again we packed everything up and headed up into the woods. Luckily there weren't too many RAM sticks, so this wasn't going to take all day. All we had to do was heat up the chips and knock them off into a container. Took us about 2 hours, pretty quick. Now the chips are separated from the boards. Back to the garage. Next up, phones. Look at this pile, there is a ton of them. We even found the legendary Nokia 3310, famous for being basically indestructible. And check this out, one of them has a rotating camera. Some of this still power on, believe it or not. We also came across a classic, the Nokia Express Music. Every kid in school wanted one of these. It had upgraded speakers, dedicated music buttons, even a camera. Naturally, we got curious and tested how it shoots video. Yeah, let's just say it felt better back in the day. Anyway, time to tear them down. We unscrewed the backs, remove the keypads. Whoa, look at all that gold under the buttons. And start disassembling the boards. It's the same deal as with the RAM. There is visible gold on the surface, but a lot more is hidden inside the chips, so those need to be desoldered too. And we did the same thing for all the phones. Maybe in 20 years some of this will be considered collectibles, but right now they're just outdated junk. And recovering gold is pretty much the only way to make any real profit of them. Plus, let's be honest, it's way more fun this way. With that said, prepping them is not exactly exciting. At this point we were honestly getting bored. Couldn't wait to finally get to the chemistry part. There were so many different models, all built in different ways. We ended up with one big box of shells and junk and another box full of circuit boards, some of which looked loaded. Oh, and we dumped all the phone chips into the same bin as the ones from the RAM. As for the empty cases, don't need them anymore. Next up, CPUs. We've got the standard ones, also some older ceramic-based processors, which have way more gold on them. They don't really need much prep work, since most of the gold is already exposed. And we even scored a legendary Pentium Pro. This thing holds the record for how much gold you can get from a single CPU. By now you're probably wondering what's what and where all these parts are coming from. So we started with 7 types of raw materials, and after all the prep work we ended up with 6 distinct categories: phone boards, processors, RAM contact fingers, chips, old ICs, gold-plated connectors. Each of these will be processed separately using different methods. Let's start with the chips and old ICs. First, we need to get rid of all those metal legs and solder dots. They'll interfere with the chemical reactions later on. We dump everything into a beaker and start prepping the acid mix. Distilled water goes in first, then sulfuric acid, which heats up as soon as it touches the water. After that, we add nitric acid. We seal everything up so we can take it out to the woods. We also packed up the chipsets from the motherboards. At the side, we pour out some sand to distribute the heat more evenly. Then carefully add the acid mix. Whoa! The reaction just exploded, way more intense than I thought. Definitely glad we didn't try this in the garage. And yeah, this is exactly why that reddish gas is called the foxtail. We waited for the first reaction to settle down. Then added a batch of RAM chips and phone chips. They fit in the same beaker along with the chipsets. We tried lowering the heat to slow the reaction down a bit. But it didn't really help. The reaction is self-heating. Look at all that vapor. Again, good thing we're not doing this indoors. The reaction gradually slowed down and all the metal legs dissolved into the liquid. We pulled it off the fire and… crap! Regular jars aren't great for this stuff. Anyway, the components now need to be thoroughly rinsed to get rid of any leftover acid. We heat them with clean water. Then took everything back into the garage and gave it another proper rinse with a big batch of water. And now, to get to the actual gold, we need to get rid of the plastic, just like we did with the MacBook chips. But this time, the scale is way bigger. We lit up a bonfire. Placed a steel pan on top and dumped in all the ICs. To boost the burn temperature, we used a blower again to force air into the fire. Oof, I had a feeling this was going to take a while. Sure enough, evening rolled around. We originally planned to burn everything in batches, but it was taking forever, so we built a second fire pit right next to the first one. Same setup, same steel pan. This one was for the higher value chips, RAM chips, phone chips, and the motherboard chipsets. From there, it was just a waiting game. We occasionally blasted the plastic with torches to speed things up, but honestly it didn't help much. The plastic gradually started to turn to white. And we sat there watching, deep into the night. Done! But we're not finished yet. We took the pans off the fire. And now we had to grind everything down into powder. For that, we used a coffee grinder. Flip the switch. And we got a fine black dust at the end. Then we sifted it to remove the metal heatsinks that were hidden inside some of the chips. Batch by batch. But then the blender died. We managed to finish the first batch, but there was no chance it would survive a second round. The next morning we bought a new blender, this one a bit more serious with an ice crashing attachment. Hopefully more durable. We kept going, grinding, sifting, and grinding again. Then we dumped each batch back into a pan for a second burn to get rid of any leftover organic residue that might mess up the chemical reactions later. Little by little the ash turned white. The whole reburn took another 2 hours. We finally took it off the fire. In the end, we had 2 full containers of powder, and somewhere in that fine gray dust is gold. But now comes the big question: how do we get it out? In the last video, a lot of people didn't really get how the gold extraction chemistry actually works. Imagine you've got a gold-plated component, but it's mixed with other metals, like aluminum, copper, tin or whatever else in there. First, we pour nitric acid over it. Nitric acid is strong, but not strong enough to dissolve gold, so it leaves the gold untouched while it eats away everything else. Then comes the key part. Aqua regia. That's a mixture of nitric acid and hydrochloric acid, and together they can dissolve gold completely. Once the gold is in solution, we just recover it back from the liquid. That's the basic idea. Hopefully that helps you understand the process a bit better. So, that ash we made earlier, it still contains gold, but it's also packed with a bunch of impurities and base metals. So our next step is to etch those out using nitric acid. We poured all the ash into beakers and once again headed out into the woods. We diluted everything with distilled water, started heating it up, and slowly added the acid. The reaction kicked in, but it wasn't that intense this time. We did the same thing with the second beaker. Then came the waiting game. We had to stir occasionally and wait for the reaction to completely stop. That took about an hour. Finally, it was done. All the impurities were now dissolved in the liquid, so it was time to filter it out. We started pouring it through the filter. But for some reason it was super slow. After half an hour, basically nothing had passed through. Turns out the ash was clogging the filter. So we tried to improvise a little device to push the liquid through with pressure. Didn't help much. In the end, we just left it overnight. Next day, we poured the filtered liquid back into a beaker. And yeah, it didn't filter well. So, for the second batch, we tried a different method. We drilled a hole in a regular jar and glued in a vacuum valve. Then sealed up the lid and hooked up a pump. The idea was that the vacuum would pull the liquid through the filter. There is actual lab glassware made for this, but well, we forgot to buy it. Still, it worked. The process went way faster this time. We pulled out the filtered solids and the leftover liquid, we poured it down the drain. Don't worry, it's safe. The acid had already reacted and it was heavily diluted, so the pipes are fine. The second batch filtered way better than the first. Now, just like we did in the last video, no need to repeat the whole thing. We prepared some aqua regia, we heated it up and poured it over the ash, constantly stirring and keeping it hot so that all the gold, hopefully, dissolved into the liquid. We kept it boiling for over an hour, adding fresh acid as needed. Now it was time to filter this gold-laced sludge. We rinsed everything thoroughly. The gold solution would pass through the filter while the leftover junk would stay on top. We repeated the exact same process for the second batch. And ended up with two separate gold solutions. From there, it's just like in part 1. We neutralized leftover nitric acid using urea, adjusted the pH, and dropped in the hydrazine to precipitate the gold. Then we dried and melted it in a crucible. This was the gold from the ICS, and it came out to just 0.242 grams. But for the RAM chips and chipsets, we got a huge beat. We didn't expect that at all. 2.7 grams. Now that's a serious result. And keep in mind that just 2 out of 6 sources. We still have 4 more to go. Before moving on, we took a break to grab a bite and air out the garage a bit, because next we'll be using a slightly different method. Let's go with the connectors next. These have exposed gold plating, so there is no point in dissolving all the surrounding metal. Can you imagine how much acid we'd need? Instead, we're going to use the Jinchen reagent from China, which I talked about in the last video. But for this amount, we'll need a lot of it. We start by pouring distilled water into a pot and heating it up to about 60 degrees Celsius, because this solution doesn't work in cold water. Then we transfer it into a bucket. We add 200 grams of Jinchen powder and mix it really well. then 44 grams of caustic soda, and 53 grams of potassium ferrocyanide. That's the oxidizer that kicks off the reaction. Mix everything thoroughly and then pour it over the connectors, making sure they're completely submerged. The reaction takes a full 24 hours. We also prepared another batch of the same solution for the remaining components. Processors next. These also have exposed gold, so we can go straight to extraction. The regular CPUs were ready to go right away, but the ceramic ones needed a bit of prep first. We popped off their lids, and underneath we found extra gold bonding wires connecting the silicon die to the contacts on the substrate. Thankfully, there weren't too many of them, so this step didn't take long. And of course the Pentium Pro, the Gold King. Had two separate chips inside. We dropped all the processors into a beaker and poured in the Jinchan solution. Same goes for the RAM fingers, but there is a twist. The boards are coated with protective lacquer, and some of the gold traces are hidden underneath it. So we stacked the RAM sticks into a beaker, then we grabbed caustic soda. Alkali works great for dissolving lacquer. We gave it a good stir and poured the solution over the boards. To speed things up, we heated the mixture. Okay, maybe a bit too much. After the lacquer was gone, we poured the used alkali down the drain. Then we rinsed the RAM stick thoroughly, so there wouldn't be any residue left to interfere with the Jinchan reaction. Once they were clean, we poured in the Jinchan. Next up, phone circuit boards. We stacked them vertically into a plastic bucket, but ran out of space, so we grabbed another one. We also dumped in all the random parts we picked out from the radio components bag. Then we poured the Jinchan solution over everything. Later we transferred the contents into a larger basin and added more solution. You'll see why in a bit. Alright, at this point we had 4 batches soaking in Jinchan, and right now somewhere in those buckets precious grams of gold were quietly dissolving. It's a relatively simple chemical reaction, and we let it run overnight. But I couldn't stop thinking about it.
Here is what's stressing me out. The reaction is supposed to run for around 5 hours, but we left it going overnight. And since there are so many metal parts in the mix, they could start prematurely pulling gold out of the solution, causing it to stick back onto the components. If that happens, we'll either end up with way less gold, or worst case, everything drops out and we'll get nothing. Yeah, can't sleep just thinking about this.
The next morning I rushed to the garage to check on everything. Turns out the CPU batch didn't have enough solution for how many processors we threw in. Most of the plating was gone, but there were still some spots left untouched. So we decided to save the old solution and pour in a fresh one. Same deal with the RAM sticks. We had packed them too tightly, but the phone boards and connectors looked fine. We let the second soak run for another half a day. And that did the trick. Even the Pentium Pro was completely stripped of its gold. We drained everything into the same container as the first batch. Look at this. These were shining just yesterday, loaded with gold. Now not a trace. We tossed all the stripped components in the trash, because all the gold is now in the solution. Next step, filtration. The jar we had was only 3 liters, and there was no way all that liquid would fit. So we grabbed a big plastic water jug, stuck a funnel in the top, dropped in the filter, and sealed it up by pouring water around the rim. We fired up the vacuum pump, and yep, it started flowing. But the jug couldn't handle the pressure, so we had to baby it, constantly turning the pump on and off just to finish filtering. We decided to keep the filters, just in case they held onto any trace amount of gold. Next, we poured the filtered solution into a beaker to warm it up. Then transferred it back into a larger bucket. Now it's time for cementation using zinc. We grabbed some zinc powder and started stirring it in. Here is how it works. Gold ions in the solution touch the zinc, grab its electrons and turn back into solid gold, which starts sticking to the zinc itself. But to make it work properly, you have to stir the mix for a good 10 minutes, then let it settle. After that, we carefully drained the excess liquid without disturbing the sediment. We even transferred it into a narrow beaker and let it settle again, just to be extra safe and not lose anything. Now we needed to get rid of the leftover zinc by adding nitric acid. Whoa, we slowly poured it in, stopping when the reaction stopped fizzing. Then it was time to filter one last time. This time the waste liquid drained through and everything we wanted stayed on the filter. So we pulled out the filter and poured aqua regia directly onto it to dissolve the gold. The solution turned a deep, rich color, which means, yep, a lot of gold in there. We neutralized the leftover nitric acid with urea, just like before, adding it until the reaction stopped. Then we adjusted the pH using a caustic soda solution, checking it constantly with test strips. There we go, neutral. Finally, we added hydrazine hydrochloride to precipitate the gold. But this time something different. Instead of usual golden precipitate, the entire solution just turned black. We waited, and there it was, pure gold, just sitting in a thick layer. We carefully siphoned off the excess liquid with a syringe, making sure not to disturb the sediment. Then we transferred everything into a crucible, every last bit. We evaporated the water and scraped the powder off the walls. Then, using a cut-off syringe, we packed it into a small pellet for melting. We sprinkled in some borax, fired up the torch, but this time the bead split into smaller pieces. So we poured everything into a clean crucible and remelted it into one solid chunk. And just look at it, a massive bead of gold, about half a finger thick. 3 grams! That's already a serious win, and we're not even close to done yet. We still have the phone boards, connectors and RAM modules waiting in line. Oh boy! Let's move on to the phones. Look how well the Jin-chan worked. It completely stripped everything. We poured the contents of both buckets into a single container. And tossed out the waste. Since we were working with a huge volume, we had to buy a 25-liter glass carboy and turn it into a DIY filtration system. We dropped in the filter, sealed it, and started pouring the solution in little by little. With the pump running, we didn't have to worry about anything clogging or overflowing. It filtered smoothly, gave us enough time to grab a snack. And yeah, we kept the filter too, just in case. We divided the solution into 2 flasks and started heating them up to kick off cementation. Then we poured everything back into the main bucket and repeated the same steps. So we'll skip ahead a bit here. We etched out the zinc, dried the powder and melted it in a crucible. This time the bead came out a little flattened, but wow, it was dense. 4.36 grams, no way! That's wild! Next up, connectors. Junk gets tossed. Same deal. Everything else goes into the filter. Man, I'm so glad we built that carbo setup. Imagine trying to filter 17 liters without it. We cemented the gold, etched out the zinc little by little, let it settle, scraped up the powder, tossed it into a crucible, and melted it down. Another bead, this one smaller but still solid. 1.16 grams. Finally, the RAM modules. We started with a quick reheat, poured off the solution, and boom, the gold was totally stripped. Trash went to the bin. We started cementing, but while adjusting the fume extractor, it broke. It was so corroded from the acid, it just fell apart in my hands. So we had to finish the zinc etching outside. Melted the final bead. Decent size, 1.78 grams. Alright, time to add it all up. Wait, we almost forgot the filters. We burned them down. Did the usual processing. And ended up with some weird sludge. Honestly, I didn't have enough chemistry knowledge to figure out what it was, or if any gold was even left in it. But hey, we're happy with the result either way. Total yield more than 13 grams. Now, we couldn't sell it legally, but there is basically a gray market for this stuff. We had to let it go for below market price and ended up with $1,384 instead of the $1,520 we could have gotten at spot value. Still, not bad at all. This was a crazy ride of a video.
Look what happened to my suit. There are holes everywhere. Those are spots where acid hit. And this one, it literally burned right through. Good thing I had shirt underneath. There are stains all over my pants too. They totally ruined. And the table completely came apart from acid. Oh, and also acid got into my sneakers. Those stains, they are never coming out. And this, it's so brittle now it could break from a light breeze of wind.
Thanks for watching and I'll see you in next one. Peace!